For decades after the Apollo and Lunar missions, the Moon kept its secrets while humanity turned its gaze to other worlds. The last return of samples by the Soviet Union in 1976 marked the end of an era, and then, seemingly overnight, the lunar race resumed. New SpaceX rockets soared into the sky, NASA developed the Artemis program, and China quietly ventured where no one had gone before. Whispers began about strange discoveries on the far side of the Moon. What was really found beneath the lunar dust? And why is everyone going back? To begin, let us provide a bit of context. China's lunar exploration began relatively recently, in the 2000s, following an ambitious step-by-step plan. The China National Space Administration launched a series of Chang'e orbiters and landers, named after the Moon goddess, to systematically study our nearest celestial neighbor. Their goals combined science and strategy, marking the rise of China as a space power. Chang'e 1, launched in 2007, was China's first lunar orbiter. It created a 3D map of the Moon's surface and analyzed soil composition. Notably, Chang'e 1's instruments detected signs of helium-3 in the regolith, an early hint at China's resource ambitions. A follow-up orbiter was launched in 2010. With higher-resolution cameras, Chang'e 2 surveyed potential landing sites for the next mission. It flew only 9 miles above the surface to photograph possible landing zones and verify terrain safety. Just 3 years later, China achieved its first soft landing on the Moon. The spacecraft touched down on the near side, in Mare Imbrium, and deployed the U-2 rover. This was the world's first lunar landing since 1976, ending decades of silence. U-2 roved the Gray Plains carrying an ultraviolet telescope, the first lunar observatory of its kind. In 2019, Chang'e 4 was launched, a mission that would make history. Initially a backup for Chang'e 3, it was repurposed for an expedition to the Moon's far-facing side. Its goal, to become the first spacecraft ever to land there, an achievement no other nation had managed. China's methodical program demonstrated not just technological prowess but also geopolitical ambition. CNSA, directly overseen by the military, pursued dual objectives: scientific discovery and strategic prestige. Some analysts believe China's focus is driven by the pursuit of strategic resources, marking the start of a new lunar energy race. In other words, beyond national pride, the key motivation lies in the untouched riches of our satellite, metals, water, and nuclear fuel. So, on January 3, 2019, Chang'e 4 descended into the alien night of the Moon's far side and made a soft landing in the von Karman crater. This crater lies within the colossal South Pole Aitken Basin, one of the largest known impact structures in the solar system. The significance of the far side is immense. It always faces away from Earth, hidden from our radio chatter, and had remained unexplored by previous landers. Scientists had long hoped to study its ancient terrain and untouched radio environment. But the technical hurdles were enormous. Because the bulk of the Moon blocks direct communication, no probe can contact Earth from the far side without a relay. China proposed an elegant solution, a dedicated satellite called Quqiao, or Magpie Bridge. In May 2018, Quqiao was positioned at the Earth-Moon L2 point, hovering beyond the Moon with constant line of sight to both Earth and the far side of our satellite. This relay was critical. From the moment Chang'e 4 began breaking near the surface, its landing commands were relayed through Quqiao. Moments after touchdown, the probe called home via this communication bridge. Nonetheless, the landing site itself remained in total radio silence, an ideal location for new experiments. Here, Chang'e 4 deployed its U-2 rover, which rolled onto the gray powder 12 hours after landing. This is a first for humanity and an impressive accomplishment, praised NASA Administrator Jim Bridenstine, as American scientists applauded the feat. Now, from the far side, U-22's cameras captured a landscape no human eye had ever seen up close, a pitted plain under a black sky. The geology of the far side intrigued researchers. It lacks the dark lava seas that dominate the near side. Instead, it features a thicker crust riddled with craters. By exploring it, the probe could finally help answer a long-standing question: why do the two faces of the Moon differ so dramatically? And so, Chinese missions began to excavate, or rather, unseal, a multitude of findings, ranging from exotic materials to hints of resources that could serve as fuel for future colonies. However, these findings sparked not only curiosity but also provided answers to many long-standing questions. And topping the list, of course, is the isotope helium-3, a treasure in the dust and one of the most talked-about lunar resources. Rarely found on Earth, it exists in abundance in lunar soil, deposited over centuries by the solar wind. Theoretically, helium-3 could power nuclear fusion reactors, offering clean energy on an immense scale. Chinese scientists emphasized this potential. In 2020, among the samples retrieved by Chang'e 5, a new mineral was discovered, given the name Chang'e Site, Y, which interestingly contains traces of helium-3. Its appeal is striking. Just 1.44 ounces of helium-3 could produce as much energy as 5,000 tons of coal. Estimates suggest that more than 1 million tons of helium-3 are present in the lunar regolith, and that's enough to power Earth for thousands of years. Unsurprisingly, Chinese lunar orbiters and rovers have been mapping the distribution of helium-3 and analyzing regolith since the very beginning. This valuable gas may become the gold rush of future lunar mining, and the Chang'e missions are effective prospectors surveying the most promising sites. Yet not all discoveries were so predictable. In mid-2019, operators of U-22 noticed something unusual in a small crater, a shiny, textured patch that was different from the surrounding soil. The discovery of the mystery gel stirred the internet. What could be sticky or liquid on an airless moon? Volcanic glass? Meteorite melt? Or something even stranger? Chinese officials initially withheld any photographs, fueling intense speculation. When the images were finally released, they revealed a glistening, dark substance that accumulated between the dust and rocks. Scientists who analyzed its spectrum identified it as breccia, soil and rock fused by the heat of a meteorite impact. In other words, a patch of glassy lunar rock, likely rich in minerals like olivine and pyroxene, had melted into a smooth mass. Not exactly alien slime, but still a thrilling find. It resembled melted regolith samples from Apollo missions but was discovered in a completely new location. This glittering patch told a story of high-energy collisions that had shaped the Moon's hidden face. Alongside all this, amid the grey wasteland, Chang'e 4 also carried a tiny biosphere experiment, a sealed container the size of a bucket, filled with soil, seeds, and insect eggs. In January 2019, mission scientists announced a groundbreaking event: a cotton seed had sprouted inside the container on the Moon. The news came with a photo of a delicate green shoot emerging under lunar gravity, the first plant in human history to grow on another planetary body. It was a symbolic glimpse into future greenhouses. However, the little plant didn't live long. 2 weeks after landing, lunar night fell and temperatures inside the container dropped to -62 degrees Fahrenheit. Without sunlight, the sprout died as expected once the heaters shut down. But in those short days, it proved that Earth life can begin to grow, even in such distant and alien conditions. Other seeds, like potatoes, and even fruit fly eggs and yeast, were also placed in the biosphere in an attempt to create a tiny ecosystem. And although they didn't hatch or grow before the cold arrived, the experiment marked a significant milestone in astrobiology. It demonstrated that astronauts could one day grow food on the Moon, an essential step toward establishing long-term lunar bases. As one scientist put it, this is the first time humans have done biological growth experiments on the lunar surface. A tiny green leaf on a lifeless gray world became a powerful symbol of the possibilities to come.